Good evening, friends and comrades. Welcome back to MC Railways again. We're happy to announce that the very piece of I/O board of U2011 series, which I previously built last fall, has been restored to perfect quality, and the very piece of segment LED that didn't work has come back to life again. A director in the lab removed a piece of short circuit behind this board that was added while I was not able to touch this board. So now the functionalities of this piece of board has come back to life. Now we've got 5 major tasks to run through, and let's get into a quick walkthrough of them. The first one tests the 8 little toggle switches, which are the 8 ones on this red box. By showing T1, it means the first test will be executing. To activate it, let's do PB1. As you can see here, all of these switches are on the position that the 8 individual red LEDs are all turned off. While turning them on one by one, we get now all of these are turned on. So this means the SW1A is functioning alright. By turning them all off, you see it's functioning alright, and let's switch task. By coming back, pressing PB1, and task 2 is interesting. When we press P2 and move to T2 with this potentiometer VR1 at 0 position, well, technically voltage or current 0, but maximum resistance. And let's execute the test. It says that it should rise from 0 to 255 as we gradually twist. You can see all of the 8 individual red LEDs are performing binary change as it's gradually twisted towards its maximum value, which means the VR1's functioning right. Now let's switch mission again to T3. The third test basically is a test on the analog to digital conversion voltage from the temperature sensor. However, we don't have anything to heat it up. It's just detecting the natural temperature. And let's go. Let's move it a bit. Give it a bit more heat or more cool winds. Or let's just hey, you see? When blowing some hot gas to it, the indication on the 8 red LEDs have changed a bit. Even though the gas I breathe out is not hot enough, it basically indicates the normal functionality of the temperature sensor, as shown by the 8 individual red LEDs. The next mission is interesting, the photoconductive cell input circuit. Well, even though we don't have a facility to heat things up, we still have a flashlight to shine. Let's begin this task. Naturally, it's bright here. If we block it, it will soon become dark without leaking one single bit of light in. That's normal ambient light. If we introduce our super duper flashlight on the light sensor, the LDR, it soon become bright, so bright this means fortunately the LDR is sensitive to holy light. Great. Now we've come to the final mission, T5. The 7-segment display multiplexing rate. By selecting task 5, execute it. Now it's at the maximum because I've twisted the LDR to the max. Let's recover, reduce it down. Still difficult to see it multiplexing. Down, 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 down. Now as you can see, it's crazily flashing, but warm advice, it's not very healthy for eyes. Gradually twist down, down, down. 10 Hz, that's a typical value. The slowest 0.1. If it goes to 0.2, which we've done here, it would be the typical value of watches. Now, as we run through all of the 5 testing tasks, we can be certain that the quality of this very piece of I/O board I previously built still has perfect quality. Thank you for watching, enjoy, good night, but still be cautious about engineering.